The following equation describes the position of the particle as a function of time. So in part A, the average speed is distance on time. And because the particle is traveling in one direction, so the position is positive and increasing with time, well, the total distance traveled between 1 and 3 seconds can be obtained by substituting those times and taking the difference. And that's divided by the time of the interval. So the average speed is a scalar, so it'll be positive and have no direction. Now the average velocity, on the other hand, is a displacement on a change in time. So that's equal to x of 3 minus x of 1 over the change in time. So you can see that these are identical, except the average velocity has a direction. So if you get a positive answer, the velocity vector points to the right or east. Now to find the instantaneous speed, we first find the instantaneous velocity by differentiating the position with respect to time. And then if you substitute 1.5 seconds, that'll give you the instantaneous velocity, which will be positive in this case, or east, or points to the right. And the instantaneous speed is obtained by taking the magnitude of the instantaneous velocity at 1.5 seconds. And speed's a scalar quantity and has no direction. And in part C, the acceleration is obtained by differentiating the velocity with respect to time and substituting 2 seconds, you're going to get 12 meters per second squared. So really think about your units based on what you're given in the problem.